This is an IIPMT question basing on thermal conductivity. The problem is like this. A cylindrical metallical rod in thermal contact with two reservoirs of heat at two ends conducts amount of heat Q in time T. Let me stop there for a second and show what do you mean by that. He is saying that there is a cylindrical rod with two reservoirs. Here temperature is theta 1, here the temperature is theta 2. There is then flow of heat according to amount of the heat that flows according to definition of that. Rate of flow of the heat is directly proportional to area of the conductor, difference between the temperatures, and inversely proportional to the length of the conductor, right? So you can eliminate that proportionality by saying rate of flow of the heat is coefficient of thermal conductivity into area into delta theta by L. This is what given there in the problem, right? Now the metallic rod is melted and material is formed into a rod of half the radius of the original rod. Let us see what happens here, right? When rod, this is the rod, is melted and reshaped, what's remained constant is volume of that rod remains constant. It won't disappear. Volume means area into length is constant. Area of cross section, assuming it like circular, pi r square into L equal to constant. This is done in such a way that a rod is having half the original radius. When the radius is half, it doesn't sink without affecting its length. So what we can say is r square into L is constant. So r1 square L1 equal to r2 square L2. R1 square L1 equal to radius is half. R2 is R1 by 2 whole square and L2. So R1 square L1 equal to R1 square by 4 of L2. R1 square will cancel. L2 equal to 4L1. Mean to say it's not only the radius becomes half, its length also becomes 4 times of the original length. Then what is the new coefficient of thermal conductivity is the question, right? So in that case, in new case, rate of flow of the heat dq by dt equal to K remains the same, area equal to pi r square. So A dash becomes pi r by 2 whole square, that's pi r square by 4. So A dash becomes A by 4. Delta theta is same. And as I have proved, length became 4L. So what happens now? K A delta theta by L. This 4 and 4 becomes 16. This is all the heat of the first case, rate of flow of the heat of the first case multiplied by 16. Sorry, divided by 16 in the denominator. So the answer becomes Q by 16. So this is a very simple problem. This is all depending on the very definition of coefficient of thermal conductivity. But the only thing we have to be careful is when it is reshaped, its volume remains constant. When its rod's radius becomes half, it's not just the radius gets affected, its length also gets affected. Taking that into consideration, we shall solve the problem. Then only you get the right answer. That's it. And thank you for watching.